Hi class, we are on section 2.3 and we are going to talk about graphing lines. Again, something that you've done, so this should be a good review for you. So the parent function is the most basic function of a family of functions with shared characteristics. So what that's meaning is the parent function is the most basic of either a linear function, the most basic line, or maybe it's the most basic of a quadratic function, so the most basic parabola, or the most basic of any of other types of functions that we will talk about this trimester. But the parent function is the very most basic. So A, the parent function for the family of all linear functions, so all lines, is y equals x. It's y equals x. That's our parent function for linear functions. And here is the graphing of the line y equals x. So we should recognize slope-intercept form from before, and this is saying that our y-intercept is 0. So it goes through the point 0, 0. And if I go up 1, I go over 1 to get right back on the line. I've got a slope of 1 here. So this is my most basic my most basic line, and here's the graph of the most basic line. So like I said, the y-intercept of a graph is the y-coordinate of a point where a graph intersects the y-axis. So you know what a y-intercept is at this point. The y-intercept of the line y equals x is 0, or it is the point 0, 0. So let's talk a little bit about slope-intercept form. So slope-intercept form. The slope-intercept form of a linear equation is, you could probably already say this, y equals mx plus b. You probably already know that. M is the slope, you should know that as well. And b is the y-intercept. To graph a line from slope-intercept form, we first write the equation in slope-intercept form. And the most common mistake I see at this point is students put the x term second, and then they put the b term first, and then they mix up which one's the slope and which one's the y-intercept. So make sure you actually put it in slope-intercept form. Your x term comes first, and then your constant, your b, comes last. So we write it in slope-intercept form, then we identify the y-intercept. And use it to plot the point 0b, so to put our y-intercept on the y-axis. The third thing we do, we identify the slope as a fraction, and we do that as a fraction, because remember, rise over run. So this is why I like fractions, because we'll use it a lot in slope-intercept form. So we write it as a fraction and use it to plot a second point. So the numerator is the vertical, or the rise movement. So the top is the vertical or the rise. With a positive move, we move up, and negative, we move down. The denominator is the horizontal movement, or the run. And if it's positive, we move to the right, and if it's negative, we move to the left. So let's graph these equations. So let's first follow the steps, okay? And you should be able to graph these without using a graphing calculator. So no graphing calculator on here. So step 1, write it in slope-intercept. Yep, mx plus b. It's in slope-intercept. Y equals mx plus b, which is b is just negative in this case. So they're both in slope-intercept. 2, identify the y-intercept and use it to plot 0b on the y-axis. So my y-intercept here is 1. So I'm going to plot the point 1 on my y-axis. Here, my y-intercept is negative 2. So I'll plot a -2 on my y-axis. So that's the first step. We just plot our y-intercept. And then the next thing that we're going to do is identify the slope as a fraction, rise over run, to find another point. So this is rise over run. It's already a fraction. And see that negative? I'm going to keep it with the 3. So I'm going to say a rise of -3. So that means I'm going to go down 3. So 1, 2, 3. A run of 2, 1, 2, would bring me right here to this point. So down 3 over 2 would bring me right here. If I go down 3 and over 2 again, I'm going to come to this point. And then if I go back to my beginning point and go in the opposite direction, if I go up 3, I can go back to get this point. And then draw my line through there. Kind of hard when I don't have a straight edge here. One great idea for you, because you always have a straight edge around your neck, that is your ID. So make sure you use your ID to help you draw straight lines on any of your homework, your quiz, your test. But your ID is a great straight edge, and you should always, always, always have that around your neck. I have mine around my neck. I follow the rules too. So, okay, so the other graph here, we plotted our y-intercept. We did step 2. We made sure it was in slope-intercept form, so step 1. And now we're going to do our slope as a fraction. So my slope is 3, and I need to make it a fraction so I can have rise over run, so it's 3 over 1. So we do a rise of 3, so up 3, and run 1 would bring me right here to this point. So rise of 3, run of 1 brings me here. If I do it again, I come to this point, and if I go back to my y-intercept, I can go down 3 and back 1. And there's my graph. So you should easily be able to graph. This is something you've been doing for a while. So why don't you turn your notes over? So standard form of a line, another thing that you've seen before. So write the equation in standard form. Standard form is ax plus by equals c, where a, b, and c are integers, and a and b are both not 0. Because if you think about it, if a and b were both 0, both your variables would go away. So we wouldn't have an equation here. So look at number 2 here. It says to graph these, this is what we're looking at, identify the x-intercepts by substituting 0 and for y. The x-intercept is the point where the line crosses the x-axis, and I think you know that. Number 3 here, identify the y-intercept by substituting 0 for x. Again, something that we did last year. We talked about this last year. You talked about in Algebra 1, so that you should be thinking this. I know how to do this, or at least this looks familiar. This is a good reminder. So remember, the y-intercept is a point where the line crosses the y-axis. So now, after you do that, find your x and y intercepts, you just graph the lines. So let's try this. Okay, so we want to graph these lines using the x and y intercept. The first one on the left, I'm going to start by finding my x-intercept. And I always set it like this. To find my x-intercept, I let y equal 0. That's my good reminder here. So 2x plus 3 times 0 equals 12. So that's just 0. So we have 2x equals 12. If you divide both sides by 2, x equals 6. So that's the point, 6 for x, 0 for y. And that would be 1, 2, 3, 4, 5. It's just off, so it would be right over here on the x-axis. To find my y-intercept, I'm going to let x equal 0. So I'm going to say 2 times 0 plus 3y equals 12. So this goes away. I have 3y equals 12. And if you divide both sides by 3, y equals 4. So my ordered pair is 0, 4. And 0, 4 is right up here. And then you just draw the line through those 2 points, and there's your graph. It's that easy. So let's find the x and y intercept for b here. So again, Well, a good thing that you could do right now, you could pause the video and try this one on your own. That would be a great thing to do, and then come back and see if you got it right. Okay, hopefully you just did that. Hopefully you found your x-intercept, so you let y equal 0. And I do want to see this work. I want to see this work on your problems. 4x minus 2 times 0 equals -6, so that's just 0. 4x equals -6, divide them both by 4. And x equals -1.5, or -3/2. It's the same thing. It would be right in the middle, right about here. For your y-intercept, we're going to let x equal 0. So we say 4 times 0 minus 2y equals -6, and that's 0. That goes away. So I have -2y equals -6, and if you divide them both by -2, y equals +3. So y-intercept of +3 is right up here. And then we draw our line through there. And there's our graph, so not too bad. Now we're going to look at a couple of special lines. Move this up. I'm actually going to zoom a little bit, make it a little bit easier to see here. Zoomed a little too far. Okay, so graphing special lines, and that's a little crooked. You guys probably know me a little bit better at this point. I like things done right, so there, that looks better. So we're going to graph the line y equals 2. And so what this means is that every y equals 2. Every single one. So if I made a table, x, y, all the y's have to be 2. It doesn't matter what the x is. It doesn't say anything about x, but all the y's are 2. So I'm just going to plug in some values for x. Let's plot those. -1, 2 would be right here. 0, 2 would be right here. And 1, 2 is right here. And if we draw a line, that looks like this. So the graph of y equals c, so y equals any number, is a horizontal line through 0c. So every time you have y equals a number, it's going to be a horizontal line through whatever that number is. For b here, it says x equals -3, so remember that means every x equals -3. Hard time writing a -3 there. So for x, let's make a table with every one of them being -3. It doesn't matter what y is. It doesn't say anything about y, so I'm just going to pick some random values again, -1, 0, and 1, easy ones. If I do -3, -1, I end up here. -3, 0, I end up here. -3, 1, I end up here. And there's my line right there. So the graph of x equals c is a vertical line through C0. So every time you have x equals a number, it's going to be a vertical line through that number. So we've got one last problem here, a story problem to work on. It says the value of a copier is decreasing $600 per year. Okay, now decreasing means -600 per year is a hint to us that that's a rate. So let's put a little note here. We got a rate of -600. That's dollars per year. Okay, just by reading the directions or reading the words and picking out my keys, I already know I have a rate of $600 per year. And thinking about what we're studying, that's probably going to be my M. I'm probably going to be something with slope-intercept. Let's keep going. If you purchase a copier for $4,000, oh, purchase, isn't that a starting amount right there? Let's put a note there. Starting amount, and isn't your y-intercept often your starting amount? All right, write an equation. It's off the page. Write an equation 2, it should say, represent the situation. So we let y equal the cost and x equals the number of years. So here's the thing, we already picked out our rate. We know that's our M. And our starting amount, that's our b. So my equation is y, the cost, equals m, which is negative 600, times x, the number of years, plus 4,000. There's my equation. Pretty easy here. Now we're going to graph it, and we know our starting amount's 4,000, so we need to have at least going up to 4,000. And if y is the cost, we know our cost has to go on this axis. X is the number of years, so our number of years has to come down here. Put our labels on there. And our cost has to go up to 4,000. So I'm going to put 4,000 up here. If I try and eyeball it and split it about in half, that would be about right here, so that's 2,000. If I try to split those two chunks in half, here would be 1,000. This would be 3,000. And if I give about half of each of those, we know that's about the 500 point. Not exact half. I did my best though. Okay, so let's graph this. So graphing our points, let's just make a table here. So my XY, and at 0 it costs $4,000. After 1 year, I know it decreases by 600, so 4,000 minus 600 is 3,400. After 2 years, it decreases another 600, so that's 2,800. After 3,000, it goes down another 600, that's 2,200. After 4 years and decreasing another 600, it's 1,600. After 5 years, going down again 600, that's 1,000. And after 6 years, going down another 600, that's 400. And if I did 7 years and tried to subtract 600 from 400, I'd have a negative number, which we know that just isn't quite possible. So we'll stop where we're at. And I will put my graph on here. So 0, 400, or 4,000 would be right up here. 1, oh, I forgot to put years on. I need some years here. There's 1 year, 2 years, 3 years, 4, 5, 6, and we know after that it's going to go negative, so we'll just stay right there. After 1 year, it's 3,400, which would be right about here. I'm trying to write a dot, but it's not liking it. After 2 years, it'd be 2,800, which would be right about here, I'm going to estimate. After 3 years, it's 2,200, which would be right about here. And I'm looking like a pretty nice line there. After 4 years, 1,600 would be right about there. After 5 years, 1,000, which would be right about here. After 6 years, 400, right about here. And we know that it doesn't just jump in value all of a sudden. It is continuously going down. So I'm going to draw a line through here. Draw an arrow because it'll keep decreasing. Now the last part says, when will the copier be worth $500? So I'm going to estimate it first by drawing a line in here. So 500 is right about here. If I draw a line straight across, that's pretty straight. Right about there, looks to be at pretty close to 6 years. So our estimate would be, at 6 years it's 400, so we know it's not exactly 6 years. So our estimate, we're going to say between 5.5 to 6 years. And to do an exact, to find it exactly, what we're going to do is we're going to let y equal we're going to let y equal $500. It's a funny 5, I know. And set that equal to our equation. And then solve it. So I'll subtract the 4,000 from both sides. We're solving it here for x. So I have negative 600x equals 500 minus 4,000 is negative 3,500. Divided by negative 600 on both sides. So x is about equal to, because I'm going to have to do a little rounding here, 5.83 So we've got about 5.83 years. And that's really in the range that we talked about, 5.5 to 6 years. So this is the end of this lesson. If you have any questions, make sure you start them so that we can talk about them in class tomorrow, and have a great night.